All right, let's jump right in. We are about to open the file on one of the biggest mysteries in the entire universe. And this isn't about some weird exotic concept. No, this is a cosmic missing persons case for the very stuff that you, me, and everything we see is actually made of. So, right out of the gate, take a look at this. This is the recipe for the universe. And everything you've ever seen, or touched, or even thought about. Every star, every planet, every single galaxy, all of it is crammed into that tiny little slice, just about 5%. The rest? That's dark matter and dark energy. Definitely a story for another time. Today, we're focusing on our little corner of the cosmos.
So let's zoom in on that 5%. I know it seems small, but hey, it's our home. And it turns out scientists have a very specific name for this ordinary stuff that makes up our reality.
It's called baryonic matter. And really, all that means is it's stuff made of protons, neutrons, and electrons. You know, the fundamental building blocks from high school chemistry that come together to form atoms. It's the matter that plays by the rules we know, the stuff described by the standard model of physics, the matter we think we completely understand.
And what does that include? Well, all the incredible things we see out there in space. Those blazing stars, the majestic swirling galaxies, those beautiful, colorful nebulae. But it's also way more personal than that. It's the ground beneath your feet, the air you're breathing right now. And yeah, it's literally you and me. We are all made of baryonic matter.
Now, you might be thinking, okay, 5%, how can we possibly be so sure about that? Well, that number isn't just a rough guess. It's a figure that's backed up by some of the most solid, compelling evidence in all of cosmology. Let's take a look. The precision here is just astounding. Our best measurements from things like the Planck satellite have nailed it down to almost exactly 4.9%. So the really crucial point is this. We know with incredible confidence how much of this stuff should be out there. It gives us a very specific cosmic budget we need to account for.
And that confidence, it comes from two completely separate lines of evidence. First, we can look back at the formation of the very first elements, just minutes after the Big Bang. And second, we can analyze the baby picture of the universe, that faint afterglow of creation itself, the cosmic microwave background. And here's the kicker. Both methods point to that exact same 4.9% figure.
And this really shows you how strong the scientific consensus is. I mean, when you have two totally different models relying on different physics, and they both land on the very same answer that perfectly matches what we observe, you can be pretty darn sure you're on the right track. The universe's recipe calls for about 5% baryonic matter. Case closed, right?
Well, this is where our whole story just takes a massive plot twist. Because when astronomers actually point their telescopes at the sky and try to do a head count of all that baryonic matter, the numbers just don't add up. The cosmic accounting is profoundly, mysteriously wrong. And that is a huge problem. Just look at this. The difference is staggering. On the left, you've got the amount of matter our physics predicts. The amount we know has to be there. And then on the right, that tiny, tiny little bar, that's everything we can actually find when we add up all the stars, all the gas, all the dust, and all the galaxies. The gap between what should be and what is, it's enormous. Let me put it another way. When we do a complete census of the visible universe, all the shining, glowing stuff we can see adds up to less than 10% of the baryonic matter that our rock-solid theories tell us must exist. That means the overwhelming majority of it is just gone. This is the central question, the one that's kept cosmologists up at night for decades. Where is all the normal matter? Where on Earth, or in space, is over 90% of the stuff that makes up our world hiding? And this isn't some small rounding error. It's a huge, officially recognized puzzle in astrophysics known as the Missing Baryons Problem. It's a direct clash between what we know about the early universe and what we see in the universe today. But of course, scientists love a good mystery. The hunt is on, and the leading theory suggests this missing matter isn't in some bizarre, exotic form. It might actually be hiding right in front of us, in plain sight. So, the leading suspect in this cosmic case file is something called the Intergalactic Medium. The idea is that the missing matter isn't really missing at all. It's just smeared out across the vast, empty space between the galaxies, like a superheated, incredibly thin fog. So why can't we just see it? Because this gas is unbelievably spread out. We're talking maybe one single atom per cubic meter of space.
It's so faint and so tenuous that it doesn't really shine or absorb light in any way our current telescopes can easily pick up. For all intents and purposes, it's invisible.
And this brings us to a really mind-bending conclusion. We started this whole thing by separating out the weird stuff, dark matter and dark energy, from the ordinary stuff we're made of. But it turns out, even the ordinary part of our universe is mostly invisible and completely unaccounted for. We live in a cosmos where the vast majority of everything, even our own kind of matter, is hidden from view. Which really leaves you with this final thought. If our best science is still actively hunting for 90% of the most basic, fundamental stuff in the universe, just imagine what other, even stranger cosmic secrets are out there, floating in the dark, just waiting to be discovered.